Let's boogie. All right, so parent functions. What are these parent functions? Let's take a look at a few. So I have these inputs and outputs. I have done numerous. Okay, so here's another one, and it continues on. Now you can keep going with these and try to create many more. Now these ones are the common ones that we run into. Notice that basically the first one, this particular function is nothing else but simply a linear function, and it's the easiest linear function, so you'll kind of remember. I'll rewrite it looking as y is equal to just simply x. And it is a function, of course. The slope is equal to 1. It intercepts basically the origin. Now, why is this called a parent function, and why do we kind of talk about parent functions is because pretty much any linear function that you have, so any linear basically line that you're going to draw, is just either some kind of a reflection of this line. It is possibly kind of stretched out line. It is a shifted line, so you transmit it from one place to another. And as you may remember, that really all of these particular lines can be captured by y is equal to mx plus b. And really nothing else. This, okay, so this x that we have right here, it is being scaled here by your slope m, and then it is being shifted up or down by your y-intercept. And we call this the parent function, so this is called the parent function. And then this is called the family, okay, of that particular parent, because they all really just stem from that. If I would utilize Desmos, I'm going to bring this Desmos up, and it's kind of nice that we can draw this out. So here's my parent function that I have. And now if you play around with this, so of course if I make the slope 2, notice all it does is just scales the parent function, right? Now I can keep adding many more of these. So for example, I could shift that parent function. So let's say I can shift it up or down. I'm going to shift it, let's say, by 3, and notice that it just kind of shifts it up, that original function that we had. And of course, these ones we can shift, we can scale, okay? We can, make the slope negative. So let's make it negative x, okay? So that it goes in the opposite direction. So we can do all kinds of wonderful things to our actual parent function, and then we can create a family of functions, which we really just call linear functions. And those ones have a particular slope, and then they have a particular y-intercept. Now, there are other parent functions that we have. So let me remove these, okay, because this one you studied, to quite an exhaustion in grades 9 and 10, and maybe even earlier. So here's another input-output relationship, one that you are aware of, and this one is the quadratic, right? So x simply squared is called the parent function of all the quadratics that we have. Now, what happens to these quadratics? So if I would write this out, so this is my parent function right here, but how do they look like? And I'll just kind of keep them in the form where we have, and that you're aware of. So this is y is equal to, all right, so here is my scaling a, and then I have my x minus my kind of shifted over h and k. So this is the vertex, okay, of that particular quadratic, and then this is the scaling. And then of course you can scale, either make it bigger, smaller, you can reflect them, because if you make a negative, okay, so the parabolas are going to swap. And of course you can play around with this as much as you like, but this is called the parent of all of these particular functions that we have. And now, so just like your linear functions, so if I plot this out in Desmos, so here is my function x squared. So from this one, you can do all kinds of wonderful things, and you've already studied this in grade 10. I'll put up a link up above, where, you know, you basically do different reflections, you know, translations and so on, of this particular family of functions. And, you know, so here, if your a, let's say, is 2, let's say x, so that's going to be scaling this by 2. Of course, I can shift this over. So here is my, okay, let's say I'm going to shift that over a little bit. Let's shift it over a touch. Maybe let's make it negative here. So -4, so that it kind of goes down. So all of these can be, of course, shifted in different ways, can be reflected. So if I make this negative right here, so it's going to make that negative. But our parent function is just x squared, and everything else comes from that. Now, what other parent functions do we have that you maybe not as much have seen in the past? So here's an interesting one. You know, it is the square root of x. And so this is indeed a function. It's actually a function for a particular domain. And you'll see that I'm going to just graph this in a moment. And so for here, we know that we can't really take square roots of negative numbers. At least we won't get a real answer back. So our domain is going to be restricted so that under the square root, we really just have a positive. So that's something that we have. Now, the range of that, it's going to turn out that it can be really anything, okay, that we have, and it's also going to be, for kind of purposes of what we do with functions, it's also going to be positive. Now, how does this look like, and what is this kind of function that we have? So this y is equal to the square root of x, so that's my parent. Now, don't forget, really what this means is you have x, okay, to the 1/2. Right? Because radicals can always be written in this way. And this will kind of remind you of this one right here. So this is what we had right here. And notice that the family of these, okay, so if we put it into this form, you know, you had a particular vertex and then you had a scaling of a. This will actually be kind of similar. So if you think of this as just your exponent, you know, you can write the family here of these kind of also, I mean, it's not going to be the same a as our previous one, but it's going to kind of look like this. And then you're going to have an x minus h, all right, except now it's to the 1/2. And then it's going to be, let's say, plus your k, where this is going to be turning out to be your vertex. Now, it's not necessarily a vertex per se, but that's where this particular function will start. And then you're going to be scaling it, okay, appropriately. So either making it positive, negative, or, you know, blowing it up, or whatever it is that you do. And if you write this out in the radical form, then this, okay, instead of having it as a exponent, so this is just going to be x minus h, okay, plus your k, it's going to look like this. So let's graph this. We're going to graph the parent, and then we're going to graph the family, and you're going to see that it works exactly like quadratics in terms of just shifting it around and then scaling it accordingly. So here, so let me remove this one. Now I do have, okay, so here's the kind of square root. So if you see there at the bottom, so this keyboard, so just bring it back up. And as you bring that back up, you will find that there is a square root there, if you like. So that is my parent. All right, so let me kind of shift it like this. So it looks kind of funky, but notice it is blowing up on us anyway. So although it's square root, it's still kind of going, making it bigger and bigger and bigger. And notice that the domain really just starts from 0 and it's positive. The reason for that is because, again, we can't really have negative, because we can't plug in -1 and then take the square root, because we won't have an answer for that, not a real answer. So now if you want to be able to scale this, so y is equal to, and now notice, so if I put, okay, so here's the square root and x, notice if I want to shift this over, okay, so this is going to be shifting it over just by 1. So that's the blue one that you see there. Let me kind of blow it up, okay, so that you see that it's just shifted by 1. It's kind of like shifting the vertex over. Again, it's not really a vertex in this case because it's not kind of the bottom or the top. And then if you want to shift it up or down, so let's say I want to shift it up a little bit, okay, so notice it's going to shift this, okay, up above there. And now you can, of course, also scale it. So I can put y, let's say, equals to, let's maybe scale it by, I don't know, by 3. And then we're going to put the square root of x. Okay, so notice that's the green one that you see there. And it kind of starts blowing up a little bit faster because, again, you're scaling it. Now, if you make it negative, all right, so it's obviously going to go in the negative direction. So it's going to go in that particular direction. That's what we do. So that is another parent function, which is the square root function. I do encourage you to graph it, maybe even play with table of values, and then notice that in terms of kind of shifting it around, it works exactly like a quadratic. So keep that in mind. Here is another parent. Okay, so here's the absolute value. So this is an interesting one. So the absolute, you know that whatever you input, so whatever we input in here, it's just simply going to take the positive as your output. All right. And just like the other one, so this is my actual parent. So my parent is that. If you want to create the family of these, and again, so it's kind of going to look exactly the same. So you're going to have something like this, minus, again, so you're going to have some kind of a vertex there, and then you can shift it over however way you like it. All right, so this is the parent, and then this is the family, which is originating from this. So either scaling it and then shifting it around as you like. All right, so let's take a look and see how this one looks like. And again, it's beautiful with Desmos, and props to them for creating this amazing tool, which you can just kind of utilize. So there's also an absolute that you see. So again, if you click that keyboard there button, you can put your absolute value in there. So I'm putting it here. All right, so this is what I have. Okay, so that is my parent. And notice, so it's like a V. Okay, so it's basically centered there at 0, 0, and it kind of goes off. And it should make sense to you because it's just taking the positive values. So really, if we plotted y is equal to x, it would have been a straight line, right? So if I plotted this, that's just a straight line. So what we've done is we've taken that negative, and because you put absolute values of it, it just makes all of those values positive, and then that's why, okay, this absolute value looks like that. And notice now here in terms of the family, all right, so let's scale it by 2. Let's put the absolute value x. Okay, so let's say if we had that, and then now, say if I wanted to shift it around, all right, so let's say, let's shift it around by 2. So it's going to shift that over by 2, and then let's maybe move it down, 4. Okay, so let's do that. Okay, and then you'll see, okay, so notice that this has brought the vertex of this -2, -4. So it's just like the quadratics. If you know quadratics and you understand them in their vertex form, you'll understand the family of these as you're kind of shifting them around everywhere they go. All right, and then of course you can scale these, and then I can make this, instead of positive, if I make it negative, it will just kind of do a reflection over. So that's what will happen to that. And then of course you can scale it. It's going to look, so notice what happens there. Okay, so as you're scaling it, making it kind of bigger, faster. All right, so 4, it's going to make it even that. You can flatten it out, okay, by putting less than 1. So that is exactly the same way as your quadratics. That's kind of how they work. All right. So that's another nice parent, and then a family of these absolute values. Here is, a last one for you. So this one is 1 over x. So this one is a funky one. If you graph it, it looks very, very interesting. And so for this one, so what you have again, so my parent basically looks like this, and although I haven't been really writing it, so notice again, this is just f of x. These are the same things in here, okay? So that particular parent, you can of course rewrite, so x to the -1, all right? Because that's exactly what this means in terms of exponent form, and if that's the case, you're back to the same thing. So this is going to be x, minus h to the -1 plus k. All right, so you can write it like this, and this is going to be the family of this particular parent function. And if you want to write it in terms of its numerator and denominator, then what this is going to be, it's going to be a, okay, all over. And because this is -1, so it's going to be x minus h plus your k. So it's going to look kind of like this. Or you can keep that a in front. All right, so if that a is in front, you know, you can keep this like that if you want. All of these mean exactly the same thing, where that, okay, is basically going to be kind of like your central point, kind of like your vertex of your quadratic, and then this a is going to be scaling it accordingly, and you can make it negative or positive. So let's graph this one as well, and I encourage you to do it just so that you play around with it. So if I put 1 over x, okay, so notice it looks very, very odd, okay, in here. So it looks kind of strange. Notice that at x is equal to 0, if we plug that in, we get 1 over 0, and that's undefined. So x is equal to 0 is not in the domain of this particular function. It doesn't exist. And notice that's why it's not mapped here. And as x gets closer and closer to 0, okay, from the positive side, so notice if it's getting closer and closer to 0, this thing just blows up. Because the smaller you make x, 1 divided by a small number, and as this number gets smaller and smaller, the y is just going to blow up. All right, and the same thing on the negative side. And here, if you get closer to 0, this thing's just going to blow up. So that's something you want to get an intuition of. It's just, okay, so what's happening? And that is your parent. And now you can shift this parent around. So y is equal to, so notice if I put +1, okay, so it's going to shift it, okay, basically -1. So it's going to shift it to this direction by 1 from its original. And that's exactly what happened here. Okay, so it's shifted by 1 over there. And then if you want, you can move it up or down. So let's say if I shift it up by 2, okay, so it shifts the central point. All right, so that means, so here what I'm going to do is, okay, and let me graph it, -1, 2. Okay, so that is kind of the central point that you see there. All right, so that's what you have there. While the original point, okay, which was 0, 0, okay, if I label that, that's what this was. So these family, okay, functions that you have, they just get shifted around depending on what you have. And of course, you know, you can make these. So if I go back into this one, you know, if I put this 3, it just kind of starts blowing it up, right? So this is what's going to happen. If I make it negative, so look what happens there. So that's something you want to try for yourself. Notice it just will flip it around. All right, so do a reflection. And that's exactly what you saw in the quadratic. So once you understand the quadratics very well, you know, reflections, translations, and so on, you know, it makes it so much easier to understand these ones. All right, so that's all that I have for you within here. I also encourage you, okay, you can play around with many others. You know, one thing that I would encourage students to do is, because you've done up to quadratic, but you know, what would happen if you had this cubed, right? Notice what happens to this. This also can be a parent function, and then you can play around with this one and shift it around. Notice it looks much different than a quadratic. So, you know, you can play with these because you have decimals, a tool like that, or any other graphing calculators or apps, which help you a lot to get intuition into these. Notice that if I put 4, oh, this looks kind of like a parabola, except it's really squeezed at the bottom, right? But then it opens up the same way as basically a quadratic, and that's because it's now to the power of 4. And then you can continue this, you know, and see if there's patterns that you see as you kind of work with these. So these are all just parent functions that we have. And then within these functions, you know, we can play around with them and move them around. So translate them back and forth, okay, create reflections, and so on. So notice if I put negative in here, it just kind of reflects it around. All right, so that is it. Thanks for watching, and we'll see you in a future video. Bye, everybody.